Welcome everyone to another technology video here on our otherwise Linux open source and so on channel. Today a little bit more mainstream and state-of-the-art Ryzen 7000 series overclocking. In my example with sample size 1 with the 7950X and the Gigabyte Aorus Master. Why does it show that here? Elite E, why do we not have, should have probably looked there. Anyway, and one specific thing. So what we do here, previously I've shown you, previous videos talked about this. So basically this is my summary of my findings. So I'm running this board, not a paid advertisement, just the stuff we got. And Kraken set 73, it's a little bit expensive AO. 2 years ago I overkill built that with a set 63 with the Ryzen first 1350X and then 1550X, and people told me why did I use a set 63 not a set 73. At that time I didn't want a little bit more compact one, so I got this one. Also I didn't pay the full price, I got it from Amazon warehouse deals, also not a paid advertisement, just I wanted to save a little bit, so I got some open box which thankfully arrived like new. The box looks like shit, but the cooler looked like basically untouched. Saved probably a lot, and so I overclocked it, right? Yeah, obviously previously a PBO precision boost overdrive and underavoided that to quite some performance improvements, and as we are epic thread ripping, usually glibc, GCC, Linux kernel and stuff on this channel for open source and Linux, the more performance the better. So today I tried for you and kind of nearly burned my Ryzen here at 100 degrees. Yeah, that probably was a bit on the edge. So this Gigabyte has one, or like, let's first tell me, so usually AMD of course intends that you run the stuff with normal default auto settings, with the platform defaults, and then it PBO precision boost overdrives that also, is that even the name, I hope, precision boost overdrive. And so what that does is boosting that in the power and thermal limits to whatever AMD, maybe AMD advertised 5.7. So with this settings and a max boost clock overdrive here of 200, that works for me. So I got this retail, right? I'm not a preferred YouTuber. I brought this with my own money and not a paid advertisement. So probably my silicon lottery win is relatively good that works. Probably at times even with otherwise dynamic vCore of minus 0.015 or even 20, depending on your. So probably I'm relatively lucky. And so that is how it normally works, right? With a base clock of, what is it for this platform? 3500, I think. If you run the P-State driver, previous video with a Linux kernel, that even idles then down to, I think, 400 megahertz, which is crazy low, also can decrease overclocking stability. I don't run the P-State driver because not doing so and a higher 3500 megahertz base clock results in a little bit more performance for my scenario. So that is the system default, right? So that what you usually can do for unlocked processors is setting a fixed clock ratio yourself, right? Yeah, this is what I tried today. So, and on some AMD platforms like this, you can even do that per CX, CCX core complex, whatever, chiplets in there. And with that you can dial in your, because of course they are from different places of the wafer and potentially different wafers, so they are all silicon lottery different, and you can, like, if one clock's a little bit better and heat spreader and stuff, thermal conductivity, it might not even that the silicon lottery on one CCX is better, it's just like the thermals might be better. So that gives you a fixed overclock. However, you lose, usually, especially on AMD, the precision boost overdrive. What that means is you lose the single or 2 cores maximum boost of like 5.7 advertised, in my case nearly 6 gigahertz. So what some BIOS vendors, apparently Gigabyte, one of them, also offers an active overclock tuner, and that is crazy that that even works. So what that does is, they say there is this dedicated microcontroller. Maybe there is, maybe they use some system management controller. I have not verified that. I didn't go with a magnification glass over the PCB. Some, at least, so they say, their advertisement saying is some microcontroller is actively manipulating this turbo boost and clocks. I find it, as kernel developer or otherwise even hardware and Verilog and stuff, I find it crazy that that works. I would really wish this kind of signal documentation would be more open, and we wouldn't know how that works. I find it crazy that some external, apparently, or maybe we don't know what is happening there in the AGESA and on-chip microcontroller for all the voltages and frequencies. I would find it more logically if it is on AMD Ryzen CPU microcontroller, but who knows where it is. But the result of wherever it is that it is actively switching between the standard AMD precision boost overdrive, which gives you this increased single core boost frequencies of advertised 4.7, in my case nearly 6 gigahertz. So combining the best of this single clock boost, which we need for single threaded configurants and stuff, or otherwise gaming and so on, and this manually dialed in all core fixed clock ratio overclock, and basically bringing back precision PBO, precision boost overdrive. It has here two things: CPU kernel limit and CPU temperature limit. And how that works is, so that is the two thresholds within this microcontroller is switching this overclock. So in this case, I tried here various things. So one kernel limit is this, that is the current, so it's starting basically with AMD PBO precision boost overdrive until it hits this CPU kernel limit. Obviously that is not set CPU kernel limit between PBO and OC settings. It's of course, as usual with this BIOS previous video, not really documented, but that is the current limit when it switches from, so basically the CPU can single or dual core precision boost overdrive until it hits 55 amps. And then this external microcontroller switches to, because so normally the default AMD system behavior would, of course, you have more load. So what this does is externally determining how much load your CPU does, right? So the thing is, if you load a single core or two, you get this PBO. If you use too much current because you load lots of cores and threads, the current goes up and higher and you hit this limit, and then it's switching from PBO, precision boost overdrive, to this manually dialed in ratio, a fixed frequency ratio overclock. And the second limit is, it's obviously also not explained here, CPU temperature limit. So that is a limit when it falls back from this fixed clock setting overclock, your manual overclock, again back to PBO. Probably the thinking is it's too much current, too much temperature, and better before burning your CPU, better going back to the AMD blessed algorithm. So by default, of course, the defaults are whatever, maybe 45 and 80 or whatever. I set it so high so that I get more few cores boost and much longer all core overclock. So what do we get from that, right? I get from that crazy high temperatures, right? So the temperatures are easily 10 degrees hotter than what are usually hot. I mean, usually it's hovering around 90 degree for the T control and TCC D1, so yeah, CCX1, CCX2, that's of course on Linux. Obviously we run Linux everything, right? Not this Windows Hobby OS thing there where nothing really works. I've run Geekbench, I've compiled the Linux kernel, and obviously I had quite some spontaneous reboots and other random segmentation faults in GCC compiler, right? So obviously, as usual with this overclocking stuff, it needs some iterations of dialing this in, finding your limits. Here obviously some more limits. So initially I started with that. I'm approaching, depending on how much I wanna risk that, also 100 degrees. 5.4 kinda sort of plus minus all core clock, so that is over 100 megahertz higher than what AMD's default system behavior with my manually dialed in undervolting and 200 megahertz boost, CPU boost clock override and curve optimizer. I have here quite some aggressive curve optimization also. So to no surprise, it can give you even higher clocks. How this, and even this result was at the edge of stability, right? I said previously, what does all the overclocking do? Of course, AMD needs to offer a platform that is 100% stable for professionals and enthusiasts, right? And so there are, let's call this some engineering headroom of, let's call that the last 10%. That stuff is really stable, right? Like they bin this, and if they, of course, they sometimes sell super amazing silicon, perfectly binned, but nobody wants to buy it because it's expensive. So obviously they sometimes sell you amazingly binned stuff for a lesser price and then 7,500 or whatever. So depending on the silicon lottery, so what this overclocking does is removing this, I call it last 10% headroom, and of course, you need, this is why you see crashes, right? You overdrive that and it crashes, right? You dial this somehow in with cooling and so on. And yeah, it is, however, with this temperature, so I wouldn't run. So what are my findings? My finding is I can squeeze, I mean, I've felt already lucky because with my undervolting and curve optimization, with this board and this cooling and my Linux distribution, because obviously I've, like all professionals, run my own Linux distribution, I can get higher clocks. It is hard to translate to better Geekbench scores because I also found that Geekbench, for this single boost, that's not the biggest issue, but for the multi-threaded, this benchmark is also too short, right? Some benchmarks of Geekbench only run a second or two, some 3, and like between the CPU idling and all the threads kicking in and first performance boost optimizing and then all-core threading, for such benchmarks who all run only 2 to 3 seconds of stuff on this epic thread ripping silicon, it is hard to benchmark and find improvements. Yes, it was a little bit 100 scores, 100, 150 scores higher. With Linux kernel compilation, it is even harder because it runs 4 minutes, 350 to 4 minutes, whatever, plus minus, give or take, especially with the memory overclock. Of course, with other memory right now, because I need memory, I currently run the Corsair, also not a paid advertisement, just what I got, the largest memory, the largest, fastest memory I could get 2 weeks ago, so 5,600. In the meantime, I overvolted it also, because previously I couldn't get it to run at the advertised 5,600 clock. In the meantime, I overvolt this also additionally so that I can get this clock, because obviously the other DDR5-6000 kit, obviously more performance, but I need more memory. So what does it tell us in the end? So I find it crazy that this crazy setup works. It does work. I've not run long time, like 24 hours burn-in of compiling a whole freaking Linux distribution with all the 400 base packages cross-compiled from GCC, Clang, LVM, Firefox. Also, this cooling is at the limit, right? I didn't expect that. So probably if you, because obviously, as you see here, I hit 100 freaking degrees of however precise that this is in Linux. This is probably AMD engineers, but I wouldn't trust it the most, so I don't know how precise that is. And so obviously I would not run this. I think AMD officially says 95 degrees Celsius. So I wouldn't want to burn that. So my conclusion is I need more cooling, right? I didn't expect, I expected more. I had this set 63 2 years ago, for 2 years, which I was otherwise on the Ryzen 3050X and 1550X. Very satisfied. With that cooling and that CPU, with this thermal, with the thermals and power consumption and cooling output, I'm not really the most satisfied, so probably you need like obviously due, right? If I wanted to get even more performance, which probably I stop now, because the seconds translations, right? If you build the Linux kernel 3 seconds faster at this level of performance, you need, as usual, like 50% more performance to even realize it, right? So messing with that for hours is totally not my time well spent, except for this YouTube documentation to document what is possible, what are other people finding. I'm finding with my silicon, I appear to be lucky, although I have still USB glitches, right? Although not today, thankfully there. The other thing is, as Derbauer has shown here, my neighbor here in Berlin, and he deleted one and direct die cooled that. I think he had 20 freaking degrees Celsius lower temperatures, which obviously is amazing. So maybe I should go over there and ask if he wants to delete me one or do it myself. Although I'm not really feeling the most confident, like I'm doing a software, right? Sure, for the YouTube videos I could do that. Maybe I should ask if you're interested in some partnerships there. So yeah, you need cooling. The more cooling, the better cooling. I already applied his thermal compound here, which I previously used in my builds already. So I found this previously to be good. Also not a paid advertisement, just the stuff I brought here actually. So that is, I didn't got it for free. It brought the temperatures maybe down 2 or 3 degrees maybe. That is in line what I previously found, so over whatever NZXT applied there. So the last 2 weeks the last week I've run the factory applied thermal compound there. So it's not bad. I would probably run it only for the science. I've repasted that. For you playing along at home, I would probably not repaste that, but if you want to do, might be a degree or 2 or 3 cooler. But yeah, the AIO is not enough to tame that. Before I get a beefier cooler, maybe because what Derbauer also has done already, and he might apparently sell soon, is some lapping tool where you can screw like some plastic or nylon or whatever frame with some, I think, metal towers that you, like indicators, how much you sandpaper off there, and so that you like maybe remove nearly a millimeter or whatever, or like 0.8 or something. I think he had, how much lower was it? Maybe up to 6 degrees lower with just trimming this IHS by maybe a millimeter or whatever, of something of that sort. You probably need to watch his video or stuff. And so that is certainly like 6 degrees lower, could probably translate to some nice more boosting, and certainly is more efficient than grilling and overheating your nice silicon dies there and having that all cool away. I have never done that because I'm an IT professional. I usually do code, but maybe for the sake of YouTube entertainment, I might do that. So leave in the comments below. So that's basically the findings for you to take away. That is the performance levels that I can get out of that, and that crazy stuff works. I wonder if that really is 24/7, 365 days of the year stable, this crazy external microcontroller toggling between AMD PBO and fixed overclock there. That setting probably was still not stable. It compiled a Linux kernel at 100 degree, but I would, because it was just like the reboot before that crashed. So yeah, if I would spend another afternoon, which I currently don't have really time for, you probably could dial that in better with like less voltage and less heat maybe. But also another finding is that this AMD PBO works amazingly well, and I will continue to use it with my undervolting here of dynamic vCore of minus 0.015, I think, for now, and a with this override here of 200 megahertz more boost, 99 degree, which it never reaches in this PBO setting. It always starts to clock down over 90. And this curve, I could try if maybe dynamic vCore 0 and more curve optimization, if that is stable and leads to higher clocks. I have not yet tried that. But that's basically the finding for today here for this stuff. It really works, it can give you benefit, but boy, do you need more cooling, and that is not enough. And leave in the comments below, what should I test next? Grinding that IHS down, deleting this stuff, custom liquid loop, leave in the comments below. But otherwise, I'm still very satisfied with that performance, stability, thermal, and overclocking and undervolting headroom. And I'm certainly very impressed that it is stable at these temperatures and that clocks. I hope you learned something and found something interesting. And as usual, leave in the comments below what you think, what is your take, what do you run, what do you want me to test. And one question there, what about the ASUS ProArt 670 Creator? Site is down at the moment. I have no idea, but I wanted, so I'm not a YouTuber yet, you need to share, like, and subscribe, to spread that for companies to send me free samples like they do for my neighbor. And some more also, he doesn't usually want to give me boards because he needs them themselves, right? It's not like giving boards to your neighbor and then you get them back broken. So probably my finding is they usually are quite the same, right? Except this exotic active overclocking tuner things. I'm not sure if ASUS had that too, or that is currently a mostly Gigabyte thing. It's a crazy thing anyway. I would need to, well, certainly need to benchmark that more if it's stable. I found the BIOS sucks too, right? So maybe the iOS previous video, right, a year ago, I was really disappointed by the ASUS BIOS for the AM4 platform, for the X570 workstation ACE board here. That BIOS fried my 5950X second memory channel without even overclocking, only undervolting and some usual auto settings. So in my opinion, it was the BIOS's fault, and AMD thankfully RM8 that CPU, so thank you AMD for that, which I would actually prefer that the bloody ASUS BIOS is not overvolting a memory channel or whatever in such a way that that doesn't work anymore. I tried Gigabyte specifically because I wanted to see another BIOS. It sucks the same, if not a little bit more. So far it did not yet burn a memory channel. Knocking on plastic laminated wood shit here. And otherwise, I'm, as an IT professional previous years, not the most impressed with the state of this randomly tinkered BIOS, gaming BIOS thing. I wish it would work more stable, more reliable. And also I found in the meantime, previous video, right, the Gigabyte BIOS sucks similar. In the meantime, I found additional crazy stuff to the, you want to watch the previous video, I will not repeat everything, but in the meantime, I additionally found that some values here, usually you can use plus minus to cycle through the numeric values. Some, probably I think the platform thermal throttle limit, so some of those numeric values do not allow plus minus, like due. What the heck is that about? If you have like some numeric fields, why does like cycling, incrementing, decrementing those values does not work everywhere? It's not the only one. There are others where it also doesn't, like where you can't plus minus alter the values. And also, I think the ASUS BIOS, when you loaded profiles, and also this profiles, if you save this profiles and update the BIOS, you lose them, similar to ASUS. I really hate that too. That is really low-tech solution. And also here in the Gigabyte BIOS, if you load a profile, like you play around with overclocks and undervolting and stuff, and you load a profile and you save it, like you load the profile and save it as current values, the Gigabyte BIOS will not show you what changed, but it will show you nothing has changed, although it's maybe 10 values changed for your different overclocking and active OC and stuff. And I find this also really low-tech engineering. As far as I remember, I don't do this daily, and I didn't touch the BIOS on the AM4 the last 12 months probably, because why should I? it's working. I'm not touching that anymore. As far as I remember, at least I think the ASUS BIOS did show you, like if you loaded a profile, as far as I remember from 12 months ago, it did show you the change values. If it doesn't, then shame on ASUS too, but the Gigabyte for sure doesn't show you that. And the problem with that is, I then don't see what changed, right? You tinker with some undervolting or active OC overclocking, and you load profiles, and then you don't have a visual confirmation of like, it is plus minus whatever is this and that, right? And so this is why I find this really disappointing and not helpful to not see from loaded profiles what changed relative to your current previously booted settings. But yeah, that's it for this video. Sorry, when are we dealing what? Sorry, what are we dealing when again? I have no idea what you mean. That's it for this video. I hope you learned something, especially cooling, heat, and more cooling. And today we talked overclocking. Leave in the comments below what you want to test next. Do you want to see this Linux developer lapping his CPU, deleting his CPU, custom water blocking his CPU? But for even more performance and these temperatures, you probably need a custom water loop with a really thick water block, and otherwise direct right? Hope you learned something. Don't forget to subscribe. There's also Patreon and GitHub sponsorship and stuff. And I hope to see you next time for all the next fun stuff and testing to come. Hey, and to that, 0 frames. Also, I noticed on the AM5 the audio has some hiccups. Probably pulls audio, right? It usually is pulls audio. It didn't happen on the Steam Deck though, on the AM4, but have a good day or night.